right. So this is the problem where a ladder is 10 feet long, rests against a vertical wall. Okay, so I just drew a picture, and I drew a picture of what could be changing. So the height, depending on where it is, depending on where the ladder's sliding, the height can change. And then the x, same with the distance at the bottom. You notice as something slides, it looks like the distance over here gets smaller. Or bigger. And so we'll call those h and x because those could be changing. But the ladder, that's never going to change. It's always going to be 10. Okay, so I did that. And we want to figure out a rate. And it's the rate of the bottom of the ladder sliding away. So that looks like we're finding the distance. Well, that one is the distance of x over time. So it looks like that's going to be 1.2. We want to figure out how fast is the angle. Oh, so how fast an angle. So it looks like we're looking for the change in an angle over time. This is between the ladder and the ground changing from the bottom. Okay. So it looks like this would be our angle right here. So we're wanting to find the change in the angle. That's what we're looking for. So it looks like we're going to need to start with an equation that has an angle in there, and it also has an x in there. Then we can get the derivatives, so then those can get, we can have the dx's and d thetas. So one I can think of using this and angles, it looks like that's just going to be a sine. No, cosine. Because cosine is also known as the adjacent over the hypotenuse. So the adjacent side is going to be x. The hypotenuse is going to be 10. Okay, so I'm going to move the 10 over by multiplying. So x equals 10 cosine theta. All right, now using some calculus, we can take the derivative of both sides with respect to t. So I'm going to do that. So d dt and also d dt. So it looks like this is just going to be dx dt. And the right side, it looks like it's just going to be negative 10 sine of theta. But since it's dealing with theta and not t, we have to multiply it by d theta, dt, using implicit differentiation. Okay. So notice right there, we have dx dt. Okay, we know that. So that's 1.2. Okay. And now we need an angle for theta. Negative 10 sine. We need something in there, and we're looking for d theta dt, so we can leave that there. Okay, so we got to somehow figure out that angle right there. Put a negative out there. Well, maybe. Oh, it does give us the information that at this specific time, it's 8 feet from the wall. So let's draw a different triangle for when we freeze it in time. It's going to be 8 and 10. Okay, so this angle right here. Okay, this is a right triangle. Well, notice we can use the Pythagorean theorem. So if we want to find this h at this specific time, that means we have h squared plus 8 squared equals 100. No, 10 squared. Okay, so 64, this is 100. And we want to find h squared. Subtract it over, it looks like we get 36. This is going to be h squared. H is going to be plus or minus the square root of 36, which is going to be plus or minus 6. Okay. But since this is dealing with a real world application and the height looks like it's going to stop at 0, looks like we don't need to worry about that negative. So we're going to focus on the positive 6. Okay. Wait a minute. We actually don't need the angle. we know what sine of theta is in this case. Sine is going to be the opposite over the hypotenuse. Okay, so in reality, remember we said this is going to be 6. Sine is going to be 6 divided by 10. Okay, so right here we have 1.2 equals negative 10, and then sine, remember, is 6 divided by 10. All right, d theta dt. Okay, and now I'm going to move this. I'm going to copy that, and then I'm going to move this over here to the left because we have a little more room. All right, well, I noticed that the 10s can cancel out. I love that. So now it looks like we're dealing with 1.2 equals 6 d theta dt. Oh, just divide by 6. Negative 6. Negative 6. All right, so d theta dt is going to be 1.2 divided by negative 6. Okay. Putting that in a calculator. Looks like it's going to be about 0.2. 0.2 negative. Okay. And that's it.